So ACES is an acronym. It stands for the Airspace Concepts Evaluation System. And in a nutshell, it's a simulation of the air transportation system. So it simulates what all of the flights that operate during a day are doing. It also simulates the operations that are going on at the airport and the operations that are going on at the air traffic control facilities to keep the traffic flow efficient and also make sure that the airplanes are safe.
Simulating the air transportation system is very complex, requiring the ability to model behaviors for tens of thousands of entities. To do this, ACES uses an advanced agent-based architecture, allowing researchers to model the behavior of each agent within the national airspace, including pilots, airports, aircraft, and air traffic controllers.
So every entity in the airspace is modeled as a self-contained agent. The agents are autonomous, and you can also model the interactions between them based on realistic protocols and rules that govern their behavior. Its use of agents allows the researcher to modify the existing functionality and add their own models. It allows you to transform the airspace system from its current real-world model to a new model and see what happens to the system performance if you do that.
Transforming the national airspace is the mission of air traffic management researchers at the University of California, Santa Cruz. Working in collaboration with colleagues at NASA's Ames Research Center and the Federal Aviation Administration, UC Santa Cruz researchers use ACES to conceive and test new air traffic management concepts, while at the same time studying the performance impact of these concepts throughout the national airspace.
ACES computes, for example, delays, it computes throughput, it computes arrival rates at airports, departure rates at airports. It provides the position of each aircraft in the airspace. It tells you which airport pairs had more delays compared to others. So it essentially allows you to evaluate whether the operation is equitable. Is it equitable to all the players, all the stakeholders in the national airspace system?
While ACES provides an excellent platform to evaluate the system-wide impact of next-generation air traffic management concepts, its agent-based architecture makes it easy for researchers to model new automation technologies. Technologies designed to minimize air traffic controller workload and increase system throughput.
Currently, the airspace system is divided into 22 centers, 20 in the continental United States. Each one of those centers is divided into a number of sectors. Each sector is controlled by one or more controllers, and the controllers specialize in the entire center. However, the way the sectors are defined may not be efficient for all flights in the system. Some days, a different configuration may be appropriate. So one of the technologies that are being investigated for the next generation airspace system is to change the airspace configuration, change the boundaries of sectors dynamically to reflect the patterns of traffic, and this way help to minimize the controller workload.
So there are concepts such as wind optimal concepts, which actually enable airplanes to fly along wind optimal trajectories, which are fuel efficient trajectories. But when you try to fly those trajectories, the airplanes, as they fly through regions of airspace, air traffic controllers have to ensure that they are separated. So one of the efforts that we are currently carrying out is to assess the impact of wind optimal trajectories on sector controllers, trying to see if it would cause some sort of congestion, because that would necessitate other automation tools that would have to be designed to ensure fuel optimal operations.
With the current air traffic management system operating at near capacity, New automation technologies will be required to not only support future growth in the national airspace, but also help address the systemic congestion and capacity issues that currently cause over 94% of flight delays. Delays which the Congressional Joint Economic Committee says cost the U.S. economy over $41 billion a year.
Automation, I think, will play a major role in increasing the capacity and throughput of the airspace system. There are a number of activities and tasks that a controller does nowadays that do not require human intervention. A lot of the communication, a lot of the interaction between pilot and ground, between sector controllers, can be handled electronically. And there's no reason for a controller to have to worry about sending a message, waiting for a voice response and acknowledgement from the pilot. Most of it can be done automatically.
By developing new concepts that automate many tasks within the air traffic control system, many systemic issues can be resolved, improving air transportation efficiency and safety while contributing billions of dollars in savings to the U.S. economy.